Hello, space enthusiasts, and welcome to Astronomy Daily. I'm your host, Anna, and I'm thrilled to guide you through the cosmos today. We've got a stellar lineup of stories, so buckle up. Today, we're diving deep into how solar storms are messing with our satellites. Then, we'll be taking a first-ever peek at the sun's poles. It's about time, right? After that, we'll question the very fabric of reality, or at least the stuff inside black holes. Plus, we'll check in on SpaceX's ambitious Starship plans down in Florida. It's gonna be huge, literally. And finally, we'll wrap things up with a dusty mystery surrounding Uranus's moons. Turns out, they're weirder than we thought. So, yeah, let's jump in, shall we? All right, first up, let's talk about space weather and how it's messing with our satellites. You know, those expensive bits of kit we kind of rely on. So, geomagnetic storms. Basically, when the sun throws a tantrum, they can actually cause satellites in low Earth orbit to, well, lose altitude faster than expected. This is called orbital decay, and it's not good news, folks. See, when these solar storms hit, they puff up Earth's atmosphere, which means satellites have to fight against more drag. But there's some new research out there that suggests we can actually design satellites to be less susceptible to these solar storms. Apparently, it's not just about predicting the storms better, but also about tweaking the spacecraft themselves. One of the researchers, Yoshita Barua, found that different types of solar events have different effects. You've got your coronal mass ejections, or CMEs, which are like huge explosions of plasma from the sun, and you've got these high-speed streams coming from coronal holes. These create what they call stream interaction regions, or CIRs. And get this, the study found that CIR-induced storms, even though they're generally weaker than CME storms, can actually be more damaging to satellite orbits because they last longer. Go figure, huh? The researchers looked at data from ESA's swarm satellites and found that during a strong CME storm, a satellite decayed 37 meters. During a more moderate CIR storm, a satellite decayed almost 100 meters. They also looked at something called the ballistic coefficient, which is basically how well a satellite cuts through the atmosphere. Satellites with a lower ballistic coefficient, like the International Space Station, are more affected by these storms. So the takeaway here is that better space weather prediction is important, but so is designing satellites that can weather the storm, so to speak. Keeps those birds in the sky for longer, you know? Now, for something truly awesome, humanity's gotten its first glimpse of the sun's poles. Yeah, you heard that right. The European Space Agency's solar orbiter, it's like, changed the game. I mean, think about it. Every single picture you've ever seen of the sun, probably taken from around its equator. That's because Earth and all the other planets, we all orbit the sun on this flat disk called the ecliptic plane. But solar orbiter, it's different. It tilted its orbit, giving us this unprecedented view from above and below. Talk about a stellar selfie. The images were actually captured back in March, but they're just blowing minds now, showing the sun's south pole in all its glory. The spacecraft used a bunch of fancy instruments, the polarimetric and helioseismic imager, or PHI, the extreme ultraviolet imager, which is EUI, and the spectral imaging of the coronal environment, SPICE. Each one sees the sun in a totally different way. The PHI maps the magnetic field. The EUI studies the superheated plasma in the corona, which is way hotter than the sun's surface. I mean, how does that even work? And SPICE, well, it can capture light emitted by plasmas at different temperatures, helping us model the sun's atmosphere. One of the coolest discoveries so far? The magnetic fields around the sun's south pole, they're a complete mess. Like, instead of nice, orderly north and south poles, you've got both polarities all mixed up. Apparently, this happens when the sun's poles are about to flip, which is part of its 11-year cycle. But get this, the solar orbiter also helps scientists track different elements as they move through the sun, measuring the speed of carbon atoms being ejected from the sun and seeing the flows in 3 dimensions. The mission's still ongoing, so there's a lot more to come, but this is a huge step in understanding how our sun works and how it affects, well, everything. All right, let's dive into something that's going to make your head spin a little. Black holes. Specifically, what's inside them. So remember how we've talked about singularities before? That point at the center of a black hole where everything gets crushed into infinite density, yeah? Well, physicists, they're still not super happy with that idea because it kind of breaks the known laws of physics, which, isn't ideal. There was this research earlier this year that proposed a solution. It suggested modifying Einstein's equation so that gravity acts differently in supercurved spacetime. This would supposedly replace the singularity with a highly warped but static region. Sounds promising, right? Well, not everyone's convinced. One physicist, Nikodem Poplawski, he's got a few major issues with this theory. First off, it needs 5 dimensions to work, and as far as we know, we're stuck with 4. Secondly, the interior of the black hole would have to be static, and Poplawski says that gravity equations predict that it can't be. And thirdly, the model adds an infinite number of terms to the equations just to get rid of the singularity. He argues there's no real solid physical reason for that. It's just like math for math's sake, he says. Now, most other attempts to solve this singularity problem, they try to merge general relativity with quantum physics, which is another can of worms entirely. String theory is one of those attempts, but it's got its own problems, like needing even more dimensions and the fact that there's no experimental evidence for it. Poplawski thinks the only way we'll ever truly understand what's at the heart of a black hole is if, get this, every black hole creates a new universe. Yeah, he's been working on that hypothesis since 2010. The idea is, if our universe was born in a black hole, we might be able to find evidence of it in the cosmic microwave background radiation, or maybe even in gravitational waves. It's a long shot, but hey, it took 100 years to detect gravitational waves after Einstein predicted them. So who knows? Maybe in a few decades, we'll finally crack the black hole code. Okay, switching gears completely. Let's talk about Starship. You know, SpaceX's giant rocket that's supposed to take us to Mars and stuff. Well, they're making some serious progress in Florida. SpaceX wants to launch Starship from the Space Coast, and they've been working on getting all the paperwork sorted out. Specifically, the Department of the Air Force just released a draft environmental impact statement, or EIS, for Starship launches from Space Launch Complex 37. That's SLC 37. This document outlines SpaceX's plans for the site. Now, SpaceX has wanted a Starship presence in Florida for a while. They even had plans to build Starship vehicles there, but they ended up focusing on Starbase in Texas. They are still building the heat shield tile factory, though. That's still going on. They also started building a Starship launch tower at Launch Complex 39A at Kennedy Space Center. But that kind of stopped for a bit, too. But earlier this year, work resumed to apply all the lessons learned from the first Starship launch. So while all that's going on, SpaceX has also been working on a Starship launch site at Space Launch Complex 37 at Cape Canaveral Space Force Station. The Air Force says that the proposed actions for SLC-37 won't negatively impact the environment or the public, which is good news. There's going to be a public comment period so folks can share their thoughts on the draft EIS. After that, the comments will be evaluated and a final EIS is expected in the fall of 2025. SpaceX doesn't have to wait, though. They already have limited access to the site and have been working on demolishing some old structures to make way for new construction. So why SLC-37? Well, the draft EIS says it's to support national security launches with Starship. SpaceX already has 2 Starship launch pads at Starbase, but they're not on a military base, and Starbase is not really suited for the requested 76 launches per year. 76! That's a whole lot of launches. Plus, the Air Force already awarded SpaceX a contract to study using Starship for point-to-point cargo transportation. The site would eventually have 2 Starship launch pads, each with a launch mount, a launch integration tower, and a flame trench. And get this, the launch integration towers are going to be taller than the ones at Starbase, like almost 200 feet taller. Wow. They're also planning on building up to 2 potential catch towers to support the high launch cadence. Of course, launching that many rockets requires a lot of propellant. So, SpaceX is planning to build a natural gas pretreatment system, a methane liquefier, and an air separation unit. It's basically a whole industrial complex just to fuel these rockets. Now, the plans outlined in the draft EIS cover some pretty ambitious Starship variants, even some that haven't been announced yet. The numbers for thrust, rocket height, and propellant capacity are all way beyond what Elon Musk has been talking about. This is likely because SpaceX wants to future-proof the study and make sure it covers all future versions of Starship. Under the current plan, launches from SLC-37 could begin in 2026, and SpaceX would need an additional 450 employees or contractors to support the operations. Initially, Starship stages would be built at Starbase and then transported to Florida on barges. But eventually, SpaceX plans to build its own Starship manufacturing facilities in Florida. With all of these launches, it will bring the total Starship-related activities in Florida to over 600 per year, a busy year ahead for the Space Coast. Okay, so shifting our gaze now to the ice giant Uranus, the one that's tilted on its side. New data from the Hubble Space Telescope is showing us some pretty interesting stuff about its moons. Turns out those moons are gathering dust, literally. Now, Uranus has like 28 known moons, and scientists have always thought that Uranus's weird magnetic field would leave visible marks on them. But these new Hubble observations of Uranus's 4 largest moons, Ariel, Umbriel, Titania, and Oberon, show no clear signs of radiation damage. What's really interesting is that the 2 outer moons, Titania and Oberon, are actually darker on their leading sides. So, the opposite of what scientists thought. The theory is that the darkening isn't from Uranus's magnetic field at all, but from dust. Hubble's data points to a slow inward drift of dust from Uranus's distant, irregular moons. These outer moons are constantly getting hit by tiny meteorites, which kicks up dust particles that then gradually spiral inward over millions of years. As Titania and Oberon travel through this dust cloud, they're accumulating the particles mostly on their leading sides. It's kind of like, driving really fast on a highway and all the bugs are hitting your windshield. Yeah, that's kind of what's going on with these moons. The inner moons, Ariel and Umbriel, don't show any significant difference in brightness between their leading and trailing sides, probably because Titania and Oberon are shielding them from the drifting dust. Now, as for Uranus's magnetic field, researchers think that its effects might be more subtle or complex than they originally thought, that it may still be interacting with the moons, but not in a way that creates strong contrasts on their surfaces. To learn more, the team has scheduled follow-up observations with the James Webb Space Telescope, within the next year. Using infrared imaging, Webb will be taking a closer look at the same moons, potentially confirming whether it's dust, radiation, or, heck, a combination of both that's shaping their surfaces. I can't wait to find out more, can you? Well, that's all the space news we have for you today. I've been your host, Anna. I hope you'll join me again tomorrow for more Astronomy Daily. Don't forget to visit our website at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. You can also subscribe to the podcast on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts. Thanks for tuning in, and keep looking up. You never know what you might see. Bye.